All right, let's go over the 7.173 quiz. Got proportions, some indirect measurement, and let's kind of try to see how to do some of these. If you missed any, you'll see why. All right, number 1 through 4, we're just cross multiplying. Starts easy, gets a little tougher. So we kind of cross multiply here. We get 3x equals 42. Divide both sides by 3. And should get x equals 14 there for the first one. Number 2, get 9x. Then you got to distribute the 5 times both pieces. So be careful. That should be a plus 5 right here. Some people may have put plus 1, and that'll kind of mess you up because you got to distribute the 5. So subtract 5x from both sides. You get 4x equals 5. And divide, and we get an answer of 5/4 or 1.8. Either one should work. Or not 1.8. What am I doing? 1.25. Number 3, 10 times 9 is 90. Got 5x, subtract 20. And I'm going to add 20 to both sides. So we get 5x equals 110. Divide, goes in there. Looks like 22 for number 3. Number 4, both ways we have to distribute. So we have a 5x minus 10 on one side, 3x minus 18 on the other. So I'm going to move my x's to the left here. So that gives me 2x. And then to get numbers on the right, I'm going to add 10 to both sides, which will give me negative 8. And divide, and I get x equals negative 4. So those are just mechanics, but you're pretty much going to be doing that type of algebra on most of these problems. I guess you don't have to. There are other ways, but this is kind of the way that I've been rolling with. All right, so let's get into the actual similar triangles and similar polygons. So number 1, it says find the length of DE, and we're looking at finding this piece right here, so I'll just call it x. And it looks like DE goes with CB, which is right there. So I can set up a proportion. X is proportional to 28 as, and then I have to pick a set of sides that I know. Well, 39 is on the small triangle, and then 52 is on the bottom. So those two go together. So I kind of did little over big or top over bottom. I'm going to cross multiply, and I get 52x, not 5x, 52x equals, and 39 times 28, let me cheat, grab a calculator here, so 39 times 28, looks like 1092. And then we divide both sides by 52. So divided by 52. And looking like 21. And I just want to kind of ask myself, does that make sense? And yeah, 21 is smaller than 28, so that's a good sign. It's not half. It looks like it's about 3/4. So 13, I believe, is 3/4 of 52. So that checks out. Number 6, state if they are similar. So yes or no question, but you need to test by checking the proportion. Okay, you need to see if all sides are in proportion with each other. So first of all, we got to see who goes with who. So DE should go with SR. So DE goes with SR. So I need to check, 50 over 20, that's one proportion needs to be checked. Then I got FE and RO, so I need to check FE to RO. That's not O, that's Q, my bad. Over 13. And then I need to check the one that's left. I need to check the 60 over 24. And I'm asking, I don't know these are equal, but I'm asking myself, are these guys equal? When there's 2 of them, you can just check the cross products. When there's 3 of them, you could just divide. There's different ways to do it. But when I check these proportions, 50 divided by 20. Well, that's 2.5. So, basically the big triangle is 2.5 times larger than the small triangle. And when I try 30 divided by 13, I'm only getting 2.3. So there's really no need to go any further. I know that these are not in proportion. So the correct answer here is no. All right, moving on down, number 7. So we have quadrilaterals here. Find the value of x. Well, x is down here at the bottom. So I got to involve the side that's with x. So I need to go little over big bottom, little bottom, big bottom. And then I could pick, it looks like I have to pick this side because that's the only part that I have both pieces. So 25 over 30. Little cross multiply action coming here. 75x, 900. Boom. So we go 900 divided by 75x. Bam. Looks like x equals 12. And what did they want? Find the value of x. So I guess I'm done. Now, it may have asked you to put the 12 in and get the 36, but it didn't really ask for that, so no need to go any further. Now we're getting into the word problems. The word problems are a little bit tougher. I think I made these only 3 points each. Pretty sure. So let's draw these out. So we have the ground. We have a 40-foot flagpole. So flag going on there. And it's 40 feet. Now we have some sort of shadow coming down. That's 15 feet. Then we have a much larger building that's 140 feet tall. And we need to figure out how long the shadow is down here on the ground. So lots of different ways to set it up, but I'm going to go little height over big height. So little height over big height. And then I'm going to go little shadow over big shadow. Didn't have to do it this way, but this is just kind of how I do it. So 40x equals 15 times 140 is 2100, which x goes into 410. That's 50. Looks like it's going to be 52 and a half. 2100 divided by 40. 52.5 feet. So that's how long the shadow is. All right, moving on down to number 9, the ladder problem. So if you missed this problem, which this was the most missed problem on the quiz, it always is. If you missed this problem, go back and look at your 7-3 practice, number 3, because in that video you will see that I tried to clean this up ahead of time in the practice. So be sure that you're trying those practice problems before you get to the quiz. That way you won't make the mistake when it actually counts for some real points. So I have the ground. I have a ladder that's leaning on a fence and then rests against a building. So we have some sort of building here. And then we have some sort of a fence. It says the ladder is 8 feet from the fence and the building is 22. So we'll put a little fence right here. That's my fence. And then the ladder is going to lean something like that. And it looks like we are 8 feet from the fence. And then we are 22 feet from the building. And what else do we know? We know that check that. The foot of the ladder is 10 feet. And the fence is 8 feet high. So that's the height. And then we need to determine the height on the building that's reached by the top of the ladder. So we need to figure out what this height is right here where that ladder touches the building at. So I'm seeing a couple triangles. So the first triangle I spot is this little fella right here. And he is an 8 by 10. So I like to kind of separate these. These are what I call overlapping triangles. I'm going to separate those two because the bigger triangle is right here. So notice 22 does not show up in your proportion because 22 is not a part of a triangle. It's a piece of a triangle, but not the whole side. The whole side of the triangle is all of this, which is actually 32. So when I draw my bigger triangle here, I have a 32 on the bottom, and then I have an I don't know for the height. So we should be able to set this thing up. We're going to do height over height, little over big, and then we're going to do bottom over bottom, bottom over bottom, and we cross multiply like always. 10h, that's 240 plus 16 is 256. Divide, divide. It looks like the height is 25.6 feet. Correct answer there for number 9. So definitely pay attention to that one. That was the most missed problem by far. Number 10, town plans to build a new swimming pool. An Olympic pool is a rectangle, and it's 50 by 25. So let's just kind of set up the Olympic pool over here. And this is 50 meters by 25 meters. The new pool is similar, but it's only going to have a length of 45, so it's a little bit shorter. So it's a little bit shorter. So we're only going, 45 here, which means our width is going to be a little bit shorter as well if we want it to stay in proportion. So we don't really know the width. We got a 50 and a 25. Over here we have a W and a 45. Find the perimeter of the new pool, okay? And it's going to be similar, so that's what we got to focus on. So let's just kind of do like big length over little length. So I'm kind of going big over little. And then on this side, I'm going to do the big width over the little width. So this is big W. That's little w. So we should be able to cross multiply. We better get something a little smaller than 25. Not much, but a little bit. So that's 50w equals 45 times 25 is 1125. And when you divide both sides by 50, looks like it's 22.5. So when I come back over here and I put in 22.5 for the two widths, I can either add up the four sides to get the perimeter, or I can just double a length plus the width. Either way, however you want to do it. But basically I have 90 and I have 45, and 90 and 45 comes out to be 135 meters, I believe this one is. So correct answer, perimeter 135 meters. Last but not least, number 10. Don't know what I did there. There we go. Back to where we were. Making a scale model of a rectangular park. The model has a length of 2 feet and 1.5 feet. So let's do our model right here. So we have a length of 2 feet, and this is 1.5 feet. The actual park is 500 yards long. 500 yards long. What is the perimeter of the actual park? Well, in yards. So we know they're both 500 yards. Those two are. But we need the sides, we need the width. And really, we don't need to change yards into feet on this one, because if we wanted to, we could kind of set up our proportion. You know, regardless if this is feet, meters, miles, whatever, the ratio is 2 to 1.5. So over here, you know, my length to width ratio is 2 to 1.5. All right. Well, over here, I have a length to width ratio that's got to match that. So this has to match up with my length to my width ratio. It's got to be the exact same. So rolling this thing out, cross multiplying, we get 2W equals 750. Divide by 2, W equals 375. So there was really no need on this one to change units. I'm good to go with the 375. And since we want the perimeter in yards, let's just add them up. So 500 and 500 gives me 1,000. And 375 and 375 is 750. So that gives us a grand total of 1,750 yards is the perimeter for number 11. All right, so hopefully that cleared up any questions you had or problems that you missed, that we can tighten things up and get ready for the big test at the end. All right, see you.